Hey, hello friends, and welcome to Retro Portal Studio, and in this video we're going to be taking a look at creating a base for this Jordan's game that I'm working on in Flutter. When the game starts, we're given with three modes, that is easy, medium, and hard. I'll select the medium and start the game. Now as the game starts, we're given with the platform and there is a ball on it. When I click on the screen, the ball launches, and on the top right corner, the score is incrementing. Now when the ball falls over, we're given a new life, and the remaining lives are 2. Now I again have to click on the screen and the ball will launch and the game continues. There are a total number of 3 lives that are given to me, and if I waste all 3 lives, then the game ends, and on the final screen I'm presented with a score and a restart button. The code for this version of the game can be found on the Git repository, the link for which will be in the description below. Right now in this repository there are 2 commits, and in this video we're going to be discussing the code in commit bug fixes for web. You can get the code for this particular commit by clicking on this browse files button, and you can download the code from here. And if you find this code useful and you learned something, make sure to start this Git repository. It really helps. Back to the project. Now in this video, rather than writing the code alongside, I think it is a better idea if I explain to you the code that I've already written. So first, let's take a look at the basic project setup. If I go to the pubspec.yaml file, in this project I only have one dependency, that is Google Fonts. Other than this, we also have this assets folder. In this we have these images, and if I open this folder in Explorer, we have these assets that we're going to be using in the application. Now one thing you need to take care of is to mention this assets folder in the pubspec.yaml file. Now taking a look at this lib folder, we have this elements.dart and this main.dart file. First, let's take a look at this elements.dart. In this, we have 3 classes, that is pvector, playball, and brick. Pvector is just a basic class with 2 properties, that is x and y, which are both of type double. We could have used offset in place of this, but since I'm planning to add a lot of features to this game, I preferred creating a custom class. We also have this playball class. In this we have this position and velocity. Both are an instance of this pvector class. We also have this radius that is of type double, a jump vector, and color. This jump vector is basically going to be useful when we need to deflect the ball when it collides with a surface. Other than this, there is also a brick class that only has one property of type rect. This rect is going to hold the top left position and the width and height of the brick. Coming to the main.dart file. Now in this main.dart file, you can see that we have a constant called modes, and this is a list of dynamic lists. Now each of these lists has an integer and a string. This integer is basically going to be useful in determining the speed of the game based on the mode that the user has selected. Other than this, we have this myApp, which is a stateless widget, and in this we're returning the material app. Now before returning this material app, we're setting the orientation for this game using the setPreferredOrientations method of the System Chrome class. We're given it a list of orientations, that is landscape left and landscape right, because we want this game to only be playable in a landscape mode. Now in this material app, we're using the theme property to set the text theme with Google Fonts.grandstandard text theme, and this is coming from the Google Fonts dependency. For the home page, we're returning my home page, and this is the class where all the magic happens. Now there are a lot of things that are happening in this my home page, so let's take a look at them one by one. First, in my home page state, we're going to create an instance of random. And this random instance is going to be used to deflect the ball in a random direction, to create a random grid of bricks, and a lot of other purposes. So we're going to use the same instance of random. Next, we're going to create an instance of global key, and this global key is going to be used in the container that will contain our game. And this is going to be useful in getting the size for the screen size, the brick wall size, and other relative sizes. Next, we have an instance of FPS, that is frames per second, and this is initially set to 1/60. And with the help of this timer instance, we're gonna refresh the state of my home page 60 times in every second. Next, we have an instance of playball, that is a class from the elements.dart, and then we have screen size, brick wall size, platform size, and brick size, and all of them are an instance of size. The screen size is basically the size of the container in which the game is being displayed. The brick wall size is the size in which the brick wall has to be displayed. The platform size is the size of this platform, and the brick size is going to be the size of each brick in this brick grid. Other than this, we also have this pointer, which is going to represent the position of our mouse or pointer in the game. we have a list of bricks, which is going to create this brick wall. And other than this, we have a list of booleans that is launched, finishing, reviving, and first game. The game is only going to be playable when this launch is set to true. By setting this finishing to true, we're going to show a laughing GIF to the user when the user has lost the game. In the same way, we're going to be setting this reviving to true when we need to show a life animation to the user. That means when the user has lost the life and we're giving a new life to the user in the game. And the last one is this first game, which is just going to be used to show a different kind of button to the user in the dialogue. That means when the user starts the game, we're going to show the button of start game. And when the first session of the game is complete, this first game will be set to false and the user will see the button to restart the game. Other than this, we have different integers. First one is the mode, and this will represent the mode that is easy, medium, or hard. We have the health, score, and this previous score. This previous score is just going to be used to show the score of the previous game in the dialogue. And this single shot kills is to limit the number of bricks that the ball can destroy in a single shot. We also have this boolean of isMobile, and this is going to be used to set the UI based on the device on which the game is being played. Now, the first thing that we need to do is to prepare the initState function. In this, we'll first set the property of isMobile, which is only going to be true if the platform is Android or iOS. We need to keep this in a try-catch block because in case of web, this platform class is not available. Next, we need to prepare the game. That means we have to get the sizes for the screen, the brick wall, platform, and brick. And we also have to set the speed and position of this play ball. For all this preparation, we have to create a setup game method, and this needs to be called as soon as the first frame of the app is loaded. And for this, we're going to be using widgetBinding.instance, and we're going to use its add post frame callback function. And this, we're going to call the setup game function, and we'll have our initial setup. Now let's take a look at this setup game function. The first thing that we do is to use the global key that we're going to be using as the key for the container that will contain the game. And we're going to use this to get the render box. And from this, we're going to get the size of the container in which the game has to be displayed. We're going to save this in the screen size. And using the screen size, we calculate the relative brick wall size. Basically, the maximum width of the brick wall is going to be the maximum width of the screen. And the maximum height of the brick wall is going to be 50% of the height of the screen. Next, we calculate the size of the platform. And we set the value of radius and color to the play ball. The width of the platform is depending on the size of the screen, and the radius of the ball is depending on the size of the platform. Now, once these basic properties are set, we're going to use the createBrickWall function to create a list of bricks that we're going to save in the state, and then we're going to create a game dialog function to show a dialog to the user so the user can start the game. The first thing that we do in the createBrickWall function is to set the bricks to empty. And then we calculate the maximum number of bricks that can be there in a row. And we set it equal to the width of the brick wall divided by the width of each brick. Now, to calculate the maximum number of rows, we divide the height of the brick wall by the height of each brick. And once we get the value for the maximum column count and maximum row count, we create a for loop to create each row of the bricks. In this, we start from a value of x to 0, and we limit the value of x to the maximum row count. Now there is a mistake that I see. I'm creating a new random instance here, but instead I could have used the random instance from the state. So I'm going to comment this new instance. Now the first thing that we're going to do in this loop is to calculate the number of bricks that we want to have in this row. For this, I'm going to use random.nextInt, and I'm going to give it a maximum value of the maximum column count. And also, to limit the minimum number of bricks, I'm using the max function and give it a first argument of 4. And with this, we can be certain that at least there are going to be 4 bricks in a row. Now there's one more important thing that we need to take care of. To give a realistic look to the brick wall, the join of 2 bricks has to be in the middle of the brick in the second row. And to have this effect, the rows in the brick wall has to be placed in an odd-even fashion. That means 2 adjacent rows cannot have an even number of bricks, which means that the first row can have even number of bricks, and the second row has to have an odd number of bricks, and the third row has to have an even number of bricks, and so on. For this, before the for loop, we create a new boolean called prevodd, and this boolean represents if the previous row had an odd number of count or not. Initially, we set it to true. That means the first row that we're going to create has to have even number of bricks. Now once we get the number of bricks for the current row, we check if the previous row had an odd count and the current row also has an odd count. We increase the number of bricks in the current row to make them even. And in the else if condition, if the previous row was not odd and the current row is also even, then we also increment the brick count to make it odd. And then we assign a new value to the priv_odd boolean, which is equal to current column count.isOdd. This is going to be a bit complex to understand, but once you do, this is a pretty simple concept. Now, once we have the final number of bricks that we want to have in the row, we need to make sure that the rows are center aligned. In this brick wall, you can see that all the rows, irrespective of the number of bricks they have, all of them are center aligned. For this, we have to calculate the left offset, and we have to add that offset to the x position of those bricks. And we calculate that offset by subtracting the width of the row from the width of the screen, and we then divide it by 2. Now we run a for loop to create the bricks for that row. In this, we create a new rect object with the values of left, top, width, and height, and we pass this rect to the rect property of the brick, and we add that to the list of bricks. Once all of this is complete, we set the state to refresh the UI. Now once this brick wall is created, we use the game dialog function to display a dialog to the user from which the user can start the game. Now for the UI of the game, let's take a look at this build function of my home page. In this, we're returning a scaffold that is wrapped by a safe area, and for the body of the scaffold, we have this layout builder, and in the builder function of this layout builder, we're returning a container. The reason we're using this layout builder is to get the constraints of the screen. We pass these constraints to the container, and we use the decoration property of the container to set a background image to this container. And this background image looks something like this. The reason for adding this background is because when the app runs on a large screen device, we want to fill the remaining area with something, because the maximum constraints for the game to render is 1280 by 720, just to maintain the performance of the game. Now, as the child of the container, I'm returning a container widget, which is wrapped by a center widget. And all of this is wrapped by a gesture detector. The reason for adding a gesture detector here is to detect the user's tap. Because when the user taps on the screen, we need to launch the game. So here, we basically check that if the game is not launched and if the game is not finishing, in that case, we launch the game, we set the new position of the ball, and this is basically the position at the center of the platform that you can see right here. And then we set the new velocity. In this case, we're giving it a velocity by setting the negative value of mode. So basically, if the mode is easy, the speed will be -5, and if the mode is hard, then the speed will be -9. Once this is done, we initiate a new timer, and we use the frames per second to run this timer 60 times every second. And every time this timer runs, we call the frame builder function. We'll take a look at this frame builder function soon. Now, the next thing that we do is we provide the on_pan update function to the gesture detector. The reason for adding this is to update the pointer when the app is running on a mobile device. And we set the state of the pointer with the new pan detail local position. Now this on_pan update is only useful to us for mobile devices, but on web or on Windows, we need to use the mouse region. So you can see here that for the container, we're giving it a width and height by using the constraints, but we give the maximum constraints of 1280 into 720. And for the child of this container, we give it a stack, which is then wrapped by a mouse region. In this mouse region, we use the onHover property to get the mouse position, and we update that position to the pointer using the mouse pointer.local position. Now the reason for using a stack here is so that we can position the elements on top of each other and on particular positions where I want those elements to be. So for the children property of stack, the first thing that I pass is a background image, which looks something like this. And just after the background, I use the bricks list and I map over the elements of the list. And for each brick, I return a new positioned widget. And for the child of the positioned widget, I return a container, which has a width and height of the brick and an image as the child. The image that we're using for the brick is this image right here. Now, you can see that as soon as the map is complete, I'm converting this to a list and I'm using the spread operator to create the child elements. After the brick wall is created, I first confirm that the game is not finished. Now, if the game is launched, I need to set the position of the ball as per the frame update, and if the game is not launched, I need to set the position of the ball in the center of the platform. Now that we set the ball position, it's time to create the platform. I once again use the positioned widget. One thing you can notice in the game is that the mouse pointer always remains in the center of the platform. For this, what we do is we get the position of the pointer and we subtract half the width of the platform from this. We set the bottom to 0 so that the platform always remains at the bottom of the game. And for the visuals of the platform, we're using an image like this. The last thing that we need to do is we need to show the score and the remaining health to the user. For this, we use the positioned widget and we position it on the top right corner. And we basically use the column and row widget to show the score and the remaining health to the user. At last, if the finishing is true, we check if the user has won the game, and we check that by checking if the bricks is empty. If the list of bricks is empty, that means the user has destroyed all the bricks. And in that case, we show the up high GIF, which looks something like this. And if the user has lost the game, we use the laughing GIF. Finally, we use a reviving boolean to show a basic scale animation for the favorite icon, which indicates that the user has used up a new health. With this, you can see that the UI for this game is quite simple. And next thing that we need to take a look at is how the collisions work in this game, because that is the core of how this game works. Now, let's take a look at this frame builder function that is being called 60 times every second to update the state of the game. So in the frame builder, the first thing that we check that if the game is launched or not. And if the game is not launched, we don't need to do anything. And if the game is launched, we update the position of the ball by using the velocity of the ball and the frames per second. We do this for both the X position and Y position. Now that we have a new position for the ball, we need to check if the ball is colliding with either of the 3 walls of the game or if it's colliding with any brick. To check the collision with the walls, let's take a look at this collisions function. For this, we check if the X position of the ball is greater than or equal to the width of the screen minus the ball radius. And if this is the case, then we deflect the ball by multiplying the X velocity by the jump vector, which is -1. So if the velocity is 2, after the collision, it's going to be converted to -2. And then we reset the position of the ball at the point of collision. We do the same for the left wall. And after this, we check if the ball has made contact with the ceiling of the box. And in this, we use the same logic to deflect the ball by changing its Y velocity. Now let's come to the most important part, which is this right here. In this, we check that if the Y position of the ball is greater than the screen height minus the platform height and the ball radius, that means the ball position has reached beyond the top of the platform, which is screen height minus platform height minus ball radius. And if the X position of the ball is greater than the left of the platform and less than the right of the platform, we have to deflect the ball from the platform. But this is not quite straightforward. We also have to check that the ball must not have crossed the screen height, because if that is the case, that means the user was unable to catch the ball and we have to take a life away from the user. And if there are no more lives available, then we have to end the game. So let's take a look at how this can be written in code. In this code right here, we're checking the X position of the ball to check whether this is between the platform. And if this if condition is true, we go to the secondary if position. And only in condition when the Y position of the ball is less than the screen height, we create a new random X velocity for the ball and we deflect the ball on the Y axis and we reset the single shot kills. And if this is not true and the ball should not be deflected from the platform, that means the user was unable to catch the ball. And in that case, we set the launch to false. And if the user has a remaining health, we decrement the health and we set the reviving to true so that the user can have the health animation. And we cancel the timer so that we could start the timer once again when the user clicks on the screen. And after an animation of 2 seconds, we set the reviving to false. And if there is no more health for the user, we set the finishing to true and we set the previous score. And after a duration of 2 seconds, we call the reset function. And in this reset function, you can see that I'm canceling out the timer and I'm resetting every stat for the game. And once again, I call the setup game. Now you have seen that the main function of the collision function was to detect the collision of the ball from the walls of the box and also with the platform. Other than this, we also check that if the user was able to catch the ball or not. And if the user was not able to catch the ball, we either revive them or we end the game. Now just after this collision, we also call the brick filter, and this function is responsible to check the collision of the ball with the bricks. In this, we loop through the bricks, and for each brick we use the rect property and use the contains function of that rect class to check that if the position of the ball lies between that rectangle. This is the main reason for using the rect as a property for the brick. And if the ball lies between that rectangle of the brick, that means that the ball has collided with the brick. Now, if the single shot kills are less than 5 and the velocity of the ball is negative, that means the ball is moving upwards, we deflect the ball to go downwards. The reason for using the single shot kills is because when the ball is being deflected from a brick, it might hit another brick. And in that case, we have to decide if the ball should be deflected or the ball should destroy the brick. So basically, this code allows the ball to deflect multiple times between the bricks with a limit of 5. And once this limit is crossed, the ball will go through the bricks, destroying them all. And each time this condition is true, we remove the brick from the list of bricks, we increase the score by 5, and for multiple bricks destroyed in the same shot, we increase the score by 10 for each brick, and we increment the single shot kills. This code is quite simple, but the only major thing that you need to understand is how these single shot kills work. And for this, I insist you to play the game and do a bit of debugging with the code to see how this actually works. Now, after detecting the collision of the ball with the bricks, in the frame builder function, we check if the bricks is empty. That means that the user has finished the game. So we set the launch to false, we set the finishing to true, and we set the previous score so that we can show the previous score in the dialog. And then we again call the reset button after 4 seconds of showing the animation. And every time at the end of the frame builder, we use the set state function to refresh the UI. This frame builder function is the core of everything that happens in the game. And one thing I need you to take a note of is that this code is not yet perfect. There are a lot of modifications that can be done in this. There are major updates for this code coming soon. So if you want to learn more about this game, I suggest you to stay updated with the Git repository. I hope you found this video useful, and if you do, please make sure to hit the like and subscribe button on this video. This helps a lot, and I'll see you next time. Peace.